Hello 30-1. Well, now it's time to put this all together and combine these transformations. And how are we going to do that when we've got all these different things? We've got vertical translations. We've got horizontal translations, vertical translations. We've got reflections, and we've got stretches, vertical and horizontal. How are we going to find out what happens when we combine these things together? Just a reminder of all we've done. So we've got the A, B, H, and K with all these notations of replacement and mapping, and now we're going to put it all together. So in each investigation, I would like you to complete it and then come back and look and see how yours compares with mine. So investigate the order that things could be done and whether it makes a difference or not. All right, so in the first one, you can see that it asks us, and you notice that the green one is the final version. So if you were to stretch it by a factor of 3, right, you get the blue graph. And if you then stretch it vertically by that factor of 2, you get the green one. Now, that's cool. How about if you did it the other way? What if you had stretched it vertically first? And so if you stretched it vertically first and then horizontally, what would it look like then? Once again, the final version is exactly the same as the other one. This is a good thing. Maybe, or maybe not. We're just trying to investigate, see. So in the next one, it says, well, what happens if a person in the first graph moves it 3 units up, so that would be the blue one, and then the final version would be then horizontally stretch it about the y-axis by 2. You end up with, well, I move it up 2, now I'm here, and then obviously when I horizontally stretch it, I get this. Okay, cool. What about if you switch the order up a bit, as in B? What if you horizontally stretched it first and then moved it up 3 units up? And we should be consistent. So let me just change those colors so that the green is always the final version. So if I started the image by horizontally stretching it by a factor of 2, so now it's here to here, and then, oh, I did it by the wrong color again. So I started by horizontally stretching it by 2, and then I moved it up 2 units. I should end up with, sorry, 3 units. I should end up with point here and 1, 2, 3, 1, 2, 3. I should end up with a graph like that. Does it make a difference whether I stretch horizontally and move or no, that didn't make a difference there either. Well, let's continue on and see when it does. So in the next version, it asks us to combine. Well, what if we sketch the image of 2 units down followed by a vertical stretch about the x-axis? Well, if I moved it 2 units, down, I would have that green graph, and then in the final version, I have the blue one, because then I vertically stretched it by a factor of 3. And in the second one, I moved it, I vertically stretched it first by a factor of 3, so there you got the green graph, and then the blue graph is where I then moved it vertically down too. Whoa. Clearly, those two are very different. The two blues are nowhere near, and obviously the order of operations for those transformation does matter, right? In investigation 4, what about a horizontal translation and a horizontal stretch? Those are two things that are working with each other. So how about we sketch the 1 unit right? Okay, well that's going to be just that simple little green graph. And in the second graph now, let's horizontally stretch it. What does that look like? Well, there's our blue graph there. Let's just make sure we're clear on those points. So we horizontally stretch it. So this one and this one, and just want to make sure 1, 2, 3, 1, 2, 3. So yeah, this one is right here, just so we got the exact points, right? All right. Well, in the next part, part B, would it matter if I If I did it the other way, would it matter if I stretched it first and then moved it? Well, let's see. So in this one, we stretched it first, then we moved it over 1. Does it make a difference there? And it does make a difference there as well. So clearly, and it may not be as obvious as the other one was, but clearly there is a difference in that transformation. So what is the order that's going to guarantee us the right method each time? Well, the order of transformation, when it does matter, and I'd like you to read through that, and we'll discuss that further in class, but I'd like you to read, and maybe through the investigations you are 100% clear. But that's something I want you to take some time to reflect on, and we'll talk more, I guess, deeply about that in class, okay? One of the things that I do want to make a note of here, and our textbook doesn't make that really clear, is horizontal stretches and horizontal transformations. I want you to write this little note, and this is going to be crucial because it will be a royal pain in the butt if you don't do this right. And I want you to write this: I will always factor out the B value for a proper transformation. You must do that. If you don't, you'll always have it wrong. And so when you start combining these things, I think it's clear when, and I just want to make a note of this up here, when somebody writes, okay, when somebody writes f at 2x, we know that that is a horizontal stretch by a half. That's cool. When somebody writes f at x plus 4, we clearly know that that is going to go to the left 4. That's good. I'm sure you guys are rock solid. But when you put these two together like this, f at 2x plus 4, and whoopsie, and if a person were to assume that that is a horizontal stretch by 2, sorry, a horizontal stretch by a half and left 4, they would be sadly mistaken. Wrong, because the only way you get this right, and that's what this note is saying, I will always factor the B value out, is the right way to do it is to say this is really f at bracket 2 bracket x plus 2. So you'll always get the horizontal stretch right when you look at it in non-factored form, but now the correct transformation that's occurring in this is there is a horizontal stretch by 1/2 and it is moving to the left 2. Okay, so what's the rule? Well, let's just highlight that one more time just to make sure that we're all on the same page. And I will always factor the B value out so that I get the correct transformation. Okay. The order that you need to follow to guarantee, it's like order of operations of bed mass or things like that. The order of operations when we're working with algebra is that, but ours is going to be SRT, stretches, reflections, and then transformation. And as we've seen, there are special cases that it works to, and you have some flexibility, and it doesn't make a difference, but there's lots that do. So the way to guarantee it is to do it in that order: stretches, reflections, transformation, and then we'll always get it right. So, for example, in the first example 1 here, describe a series of transformations that would allow A to become B. So what I said to myself was, as I looked at A to B, I said, you know what? Is there any stretches? No. I look and I say A and B are basically the same size. Was a reflection? Yes, I think it was reflected in the y-axis. That's where you get this blue graph right here. I said, well, if I took A and I flipped it around right here, okay, now I flipped it, but now they're not matching up. So if I was simply to go, well, let's take this whole graph 2 left and 3 up, I should be bang on that graph. So that's my description. There's no stretches. There's a reflection in the y-axis, and it goes 2 left and 3 up. Yeah. Okay. If you wanted the f at x notation, that's what it would look like, but they didn't really ask for that here. So in the next graph, it's saying, well, what about if you went from A to B in these graphs here? So they have a series of boxes. Okay, so look at the box from A to B and see if you agree with what I'm saying. So from A to B, I'm going to kind of uncover the picture. You'll notice there's some colors that I used for other ones. But from A to B, I said to myself, there does appear to be a horizontal stretch of 2 to go from A, that little box that you have there, to B. There's definitely seems to be twice the size. I don't think I need any reflection, but there does seem, once I've stretched it out, and you can see this blue part, if I stretch A by 2, I'm going to get this blue one right here, right? And if I want that to match up with the B graph, I would have to go left 4 and down 7. And I would have matched up the A box with the B box. Well, what about for question B? How would I get from A to C? Whoa, from A to C, there can be more than one answer, but it looks to me like, well, it's twice the size vertically, so I would have a vertical stretch by 2. Again, we're following order, right? Order of operations: stretches, reflections, transformations. There's no reflection needed, and it would have to be translated 4 up, because once you've done the stretch, you've now got this green one, and if I want to move it over to here, I'll take this corner, and I've got to go 1, 2, 3, 4 up, and I've got to go 1, 2, 3, 4, 5, 6 over there, which now would match up these 2 boxes. So that should do it. If I want to go from B to C, whoa, from B to C, there's some interesting stuff that needs to happen. That box just is not, heading in the right direction. It's a long box, whereas we need a tall box if we want it to look like C. So what are we going to do? Well, I don't think stretching it is going to do that, okay? I don't think stretching is going to do that. What we need to do, and even if I reflect it over this way, and I'm going to write this and I'll erase it, if I reflect the B and the Y-axis, well, I'll end up with a box over here. Well, that's no good, so I don't want that. And if I reflect it in the line Y equals X, well, I'll have a box something like this. Well, that doesn't do me any good either, because it's still heading in the wrong direction. So I need to reflect this in the line Y equals X. I need to reflect it in the line Y equals X. And if you do reflect B in the line Y equals X, okay, I'm just going to erase this, you end up with that box that I just erased. Once you reflect it, you end up with, oops, and I'll bring it back, that'd be easier. You end up with that box right there, right? Well, once you have it there, how do I get it to the proper position? I need to move this point. This point here has got to go 1, 2, 3, 4, 5, 6, 7, 8 up and 1 over. So by the time I get there, I will have B meeting up with C. So we're starting to see the order of transformations and how it goes together, okay? We continue on to, now we need to come up with equations. So describe what would happen if you replaced X with 3X and so on. What does that do to the graph? So now we're working with equations and pondering whether the order matters. So first off, describe these transformations. Well, in the first question it says, well, replace X with 3X and Y with Y plus 4. So let's ponder that. Well, first off, I would like it if you actually wrote the transformation. So what does that look like? Well, you got Y equals F at X, and then you got, with a replacement of Y plus 4, you have Y plus 4 equals F at 3X. It's a horizontal stretch by 1/3 about the Y-axis, and it goes down 4. Do those things matter which order you do them in? And in this one, they do not. The order does not matter. And if that makes sense, that's awesome. But again, ponder that, and this is the kind of question I'd like you to ask. If that doesn't make sense, I really want you to ask about that tomorrow. But they aren't working against each other, okay? And if you look at this one, first off, what's really important to me, I'm going to do this. First of all, what would these replacements look like? Well, they need to look like that. the green version. So if I replace y with minus 3y, I get minus 3y equals f of 2/3 x times x plus 2. This is what I see on exams sometimes, and that makes me sad, because if you write it like this, you have not actually done what we need to do, because when you replace it with x plus 2, you need to make sure that you have looked after that factored form that we talked about on the previous page. So if you write it like this, even though you think you've represented what's up here, you have not. It must be in factored form. As you ponder whether it matters whether you horizontally stretch and then move left or right, this does matter. Those things we saw previously will matter which way it goes. The vertical stretch won't matter so much, but when you are horizontally stretching and moving left to right, the order you do it definitely matters. Okay? Okay, great job so far, you guys. So one last question, and sometimes questions will ask you to do transformations in a certain order, and that's why I underline in the order shown, even though we know that this does not follow SRT. Sometimes they ask us to just do it in order so that we can follow the instructions the way they asked us to. And you might say, well, that's not the right way. That's okay. They just want us to do it this way. So the first thing we do is we move it over to the left 2. So I'm going to take this, and graph number 1 will be here like this. So now I went left 2. The second thing it asked me to do was to reflect it. So this is graph number 1. The second thing it asked me to do was it asked me to then reflect it in the x-axis. So now graph number 2, we get a graph that looks like this. Oops, that looks like that. That's number 2. Graph number 3, it asks us to then have a vertical stretch of a half. So I'm going to change colors. That would be right here and look like, just making sure, look like that. So it's about half as steep as it used to be. And lastly, they tell us that they want us to move that all 3 units down. So 1, 2, 3, and they want it now right here. And that is the final version. That was 4 and that was 3. Okay, so that's following the order they want. What would the equation look like in that transformation? What would using the replacements, what would it look like? Well, we would replace x with x plus 2, so we would get y equals x plus 2 squared, y with minus y, we get that equation. Number 3, we replace y with 2y, and that creates number 3. And lastly, translating down, we replace y with y plus 3, and in our final answer, hopefully it matches what our graph does, we get the equation of our transformed graph. All right, please continue with your assignment, and we'll see you guys next day with any questions that you have.